That's true. Good call. Okay, so yesterday you had 4 problems to do, yes?
Yeah.
I'm pretty sure I got it right. I'm a smart boy.
Oh, alright.
What does your worksheet say? Because I think I changed your worksheet.
What the heck?
I just added everything.
Oh, we're not.
Is that bad?
Am I supposed to have these answers?
I mean,
I got the last 2 now.
instead of like them with the TX, just like sort of like mix them.
I didn't want to code. Ouch, what's up?
There's a drug for my Snickers bar or something, okay?
Really?
Yeah.
Oh, I got 2 right. I got that one right.
Got the blue?
I have a killer sense. That was wrong.
Don't fly my eye.
I got that one wrong. He needs to know swell. And I got that one wrong.
Oh, there's stress
Do you know this thingy?
sign.
That's your killer. How is number 1 60? And it's rubbing up against my heel. Mason, what's 12 minus 2? What's 6 times 10?
Tuesday and Thursdays. Your inside days.
How do you not understand?
Inside day.
6 times
Inside days.
12.
After like weekdays.
No, you don't do that. You do 12 minus 2.
Okay, come on.
Then times 6, which is 60.
Close these pages. Pages. Put that away. Oh, you're going to use it for a calculator?
Yeah.
Okay, then that's fine. But when you're on other things. Anyone else need pages? Okay. Any questions on the work from yesterday?
Number 3 I have from I got times 12 minus 6 times 2.
What now? Okay, so for number 3, it's 4 times 3g plus 2. Okay, so 4 times 3 is 12g. And then 4 times 2 is 8. Yes, Bob.
So like after I got 12g plus 8, I like added them.
Okay, so it just needs to stay like this. Okay, so what Bob said was that after he got 12g plus 8, he added them. Okay, 12g and 8 are not like terms. Okay, this is a constant term, this is a variable term, so we can't combine them. Okay, so once you get here, you're done. Okay, so you cannot combine them. Where are the cheese bandits? Yep. Somebody's the cheese bandits today.
Oh, yeah, that's Brandon.
Kelsey, Brody, and Cooper. Okay,
Seems about right.
whatever.
You
You know,
didn't invite me.
what can you do? Okay, so today we are going to be working out of our books. Okay, any other questions from the homework last night? No? Okay, if you need a refresher on the lesson, I did post the video. I did have some technical difficulties with the video yesterday. It literally fell over during the videotaping, and I didn't cut it out because it was just kind of funny. So there's like a 3-minute section where Mrs. Jordan and I are trying to put the this thing back up, and it's kind of funny. So those are posted. They are posted on YouTube, but I link them through Google Classroom. So all you have to do is go to Google Classroom and hit the link, and you don't have to go to YouTube at all. So we are going to work still on the distributive property. In the book, it's lesson 4-4. It's called Expand Expressions, and we're going to be on page 208 for those who don't have the pages. So we're going to start on page 208. So our learning target for today is I can use the distributive property to simplify expressions. So same one as yesterday. So you can use your calculators today because you're going to be dealing with some fractions and decimals. So to make our math a little bit easier, we can use our calculator. So again, we're going to expand expressions using the distributive property. Now, yesterday when we were working with the distributive property, we had the model of A times B plus C is equal to A times B plus A times C. So if we had 3 times 6x minus 2, that means that 3 is our coefficient, and it's going to be multiplied by 6x and negative 2. So we distribute 3 times 6x, which is 18x, and 3 times negative 2, which is negative 6. We call these equivalent expressions because this is the expanded form of this. Okay? So they are equal, they just look different. Okay? So we're learning right now to go from here to here. Early next week, we'll learn to go from here to here. Okay, so we can do that. All right. So let's do another one just in case. Negative 4 times the quantity 2x minus 5. Okay, so what do I need to do? Bob?
Negative 4 times 2x.
Very good. Negative 4 times 2x. Negative times a positive is a negative. 4 times 2 is 8. Okay, now what? Zach?
Negative 4 times negative 5.
Very good. Negative 4 times negative 5. Negative times negative? Positive. 4 times 5 is 20. All right, questions? Good review from yesterday, right? Okay, nice little refresher. Okay, so we're going to start with our blueberry patch and apple orchard problem. A family farm plans to add a blueberry patch to the end of their apple orchard. So this is their apple orchard, and then they're going to extend it to bring in the blueberry patch. What is the total area of land that will be covered by the blueberry patch and the apple orchard? So we're talking about total area. What do I need to know to find the area of a rectangle? Everyone? Length and width. Very good. So area is equal to length times width. Right? So we have our length, and then we have our width. What information is given to us in this problem? Tucker?
That the horizontal of the apple orchard is 2.5 kilograms, and then the vertical for the whole space is 1.5.
Okay, very good. So we know the length of the apple orchard, which is 2 5/10 kilometers. And then we also know the width of the total patch. Okay, and the orchard is 1 5/10 kilometers. What information do we not know? Brooke?
The width of the blueberry patch.
Very good. We don't know the width of the blueberry patch. If we don't know a value, what can we use to represent that value? A variable, very good. Does it matter what variable we use? No, we can use x, right? Okay. So something important to us is that we want the total area of length. So we want all of this. Okay? We don't just want the apple orchard. We don't just want the blueberry patch. We want the entire area. Okay? So what is the width? What value are we going to use for the width of our area? What are we going to use for the width?
2.5x.
Okay. No, the width. Okay, we could also just say the height, I guess.
1.5.
1.5, right? 1 and 5 tenths. Now what about the length? Okay, but 2.5 is only
That part.
the apple orchard.
You would have to add the x because it's using the variable of the other length.
Good, Tucker. We need to add the x because it's this value of the blueberry orchard and, the blueberry patch, and 2.5 of the apple orchard. So we need x plus 2 and 5 tenths. Because we want all of it, the entire length. Okay, so that's why it's x plus 2.5. So then, area is equal length times width. So our area is equal to the length, which is x plus 2.5, times the width, which is 1 and 5 tenths. What's different about this problem than the problems that we did yesterday? Does it look different?
Kind of.
Okay, kind of. Okay, what's different about it?
The variable is inside.
Okay, so our variable,
It's
our
actually-
addition part is at the beginning, and then our coefficient is at the
And
end. What property says I can change the order of this?
Commutative property?
Good, commutative property, very good. The commutative property multiplication says I can change the order. So I can actually take 1 and 5 tenths, make it my coefficient, and then multiply by x and 2 and 5 tenths.
Alright.
Okay, that's okay. Okay. Can I change x and 1.5?
No.
No.
X is
Okay.
representing the length and no, the length of the blueberry patch.
Very good. X, this is our x plus 2.5. This is our blueberry, or I'm sorry, this is our blueberry patch and our apple orchard. This is the height or the length or the width of our blueberry patch and our orchard. So we can't flip-flop here and here, but we can flip-flop our entire terms. Okay, so be careful with that. So now if I'm going to use my distributive property, 1.5 times x,
Is
1.5x.
1.5x. And now I also have to distribute 2.5. So 1.5 times 2.5. You can use your calculators, guys. Get it out. Oops.
3.75.
375.
Okay. So 1 and 5 tenths x plus 3 and 75 hundredths kilometers squared. Why is it kilometers squared?
Oh, because there's two different sides.
Because we're using area, right? We're taking, so if I have x times x, that's equal to x squared, right? Okay? So when I'm multiplying my units, I'm multiplying kilometers by kilometers, okay? So I'm doing kilometers by kilometers. So that is
Kilometers squared.
kilometers squared. Okay, so whenever you see area, when you're multiplying those two units, that you squared it. Okay, volume is length times width times height. So that'd be kilometers, kilometers, kilometers. So that'd be kilometers to the third power. Okay, so area, whether it's surface area or whether it's an area of a two-dimensional figure, that's always units squared. And then if it's volume, how much goes inside the object, the 3D object, that's kilometers or units cubed. Okay. Okay. What is the expanded form of the expression 3 6/10 times the quantity t plus 5? So here's a model. Okay, this is like our box model that we did yesterday. Okay. So we've got 3 6/10. That's our coefficient. And then what's inside goes up top. So what goes in this box right here?
It should be 5.
It should be 5. So if I'm going to use the distributive property, 3 6/10 times t. Very good, Danica. 3 6/10 t. And then 3 6/10 times 5. So I know that 3 6/10 t comes down.
Then you have to multiply by 3.
Uh-huh. And then 3 6/10 times 5,
Which is 8.
which is 18. So then our expanded expression, 3 6/10 t plus 18. I used to always draw my 8s as like snowmen, and sometimes I still do. But last year Lucy got in trouble at school for drawing her 8s as snowmen. Yeah. So this is how I usually draw my 8s. 2 circles. But then,
All the way around.
That's ridiculous.
okay, but then Lucy got in trouble because I taught her how to draw her 8s like this.
You got in trouble 'cause she drew her
Yeah,
eights
she
like
drew
Yeah.
her 8s like
Oh, I
this.
used to draw 8s like that.
Yeah, no.
How do you learn to top each other?
Yeah,
What's the
I
big
used
deal
to-
in that?
And then like her 8s are the most ridiculous thing in the world. It's like this. Like that's what her 8s are.
That's how mine used to be. That's how mine used to be. I swear. They would always be
Now
like,
you're like stop the circle.
Oh my gosh, no, her teachers are like so adamant about not using the snowman 8 is what they call it. But
it works.
Wait,
It works
Similar
way
happened
better.
to me, but I wrote my A's wrong, and my kindergarten teacher got mad at me.
yeah, that's what are we gonna do?
I used to roll my 3s backwards.
Oh, I started watching my letters.
But that's like, so I was worried about that with Lucy. Like she drew, like randomly would draw like a letter backwards. I was like, Ellen, oh my God, there's something wrong with Lucy. And he goes, she's a kid, leave it alone. And then like I went to her school to like last year during kindergarten and like saw like the kids work on the wall. And I was like, oh dear God, she's not the only one, all right. Like that's a thing that kids do, you know? Like even now,
Drawing it backwards?
like drawing letters backwards.
That's how my sister
How's
used
that
to be.
possible? That seems really hard.
I knew that.
Yeah, I mean,
It's not that hard.
like, and it's not, yeah, like D's and B's are big ones.
Yeah.
But it's really interesting, and like numbers, a lot of times kids draw backwards.
I still do the bed method.
My niece
So,
always
the
just
what?
I
draws
still do the
really
bed
large
method.
letters.
What's that?
E-D.
Oh,
My name,
You can't say
you know,
my
what's
name
up?
backwards.
Your name backwards? Alright, okay, let's go ahead. So,
Because he didn't have this behind him.
now let's look at this problem here. This on the top of the next page is example number 2, so that's on 209. So x times the quantity -2 minus 5/10 y. What's different?
Oh, they're both negative numbers.
Okay, they're both negative numbers, yes.
And plus,
Brooke?
The variable comes first.
I'm sorry, what?
The variable comes
Okay, so we have a variable as a coefficient. Okay, we've only been dealing with numbers as coefficients. Is that going to change distributive property for us at all? No, it's not. So when we distribute, x times -2. -2x, very good. Your coefficient always comes first and then your variable comes second. Do not write it like this.
X2 then it's.
Okay, why?
Because it's subtracting
minus
x by 2.
You're right, now this looks like subtraction, so always make sure your coefficient goes first. Okay, so now we're going to do this. X times -5/10 y.
Oh, that would be negative 0.5xy.
Very good.
Wait,
Okay,
wait,
so
wouldn't it be y?
negative
No, because x in the alphabet goes before y.
5/10, very good. So Tucker just said the x comes before y in the alphabet, so we make sure that it is alphabetical. Okay? Does it matter? Not necessarily,
But
because commutative property order doesn't matter, but the proper way to write it mathematically is to have it alphabetical.
I don't know
Okay.
why, it's just like that.
That's kind of weird because you can just change the variable from an x to an, if I can change the variable from an x to an a, it still has the same value.
True?
Very valid.
Right?
True. I agree with that. Okay.
It's all for looks.
It's all for looks. Okay, so just because you have a variable, it doesn't change the way we do the distributive property. Okay? And when we multiply x and y, it just becomes xy. Okay? So are these like terms?
No.
No. Why are these not like terms? Okay?
Because one has an X and then the other has an XY.
Very good. This has an x and this has an xy. To be like terms, same variable raised to the same power. They have the same variable, but this one also has a y, so that doesn't make them like terms. Okay. All right. Here's the next one is going to try it. So go ahead and try this one on your own.
Whoa. Weird.
Okay, so this is in the middle of the page, on page 209. So again, either use the arrows or use the box method, whatever works for you. I will demonstrate both.
Do I have to use either of
No.
Hey, those are my initials.
Oh, that was easy.
I don't know if that's right, but I'm gonna say it's right. I don't know if it's right, but I'm gonna say it's right.
There you go.
I'm not sure if it's right, but I'm gonna make it. Whoa, what?
Yeah, that's
That's cool.
that's all teachers can do.
Did you turn it to the line drawing thing?
No.
Did you just put it? Did you like lightly bring it on?
Yeah, teachers can do that. It's called teaching.
I know.
Wait, can you do it again?
Yeah.
I think they said right now.
Guys, look, it's outside.
They just said there was one today.
That time of year I noticed it like this.
No,
The first time you did it, you couldn't even hear it. It was just gliding down.
That was
I'm magic.
Yeah.
You know,
It's called teaching.
they didn't have any more positions at Hogwarts, so I had to come here. Okay. All right, so let's look. We're going to do this problem two ways. So we've got t times -1 2 w plus 3. Okay, so t is our coefficient, and then we've got to multiply what's inside the parentheses. So t times -1 2 w. Okay,
So far, so good.
and then t times 3.
3T. No way, I'm so smart. I got it.
This is easy.
Okay,
Last year she made
Okay.
it.
so if you want to use the box method, which a lot of kids did seem to like yesterday, okay, you draw your box here, okay, your coefficient goes on the outside, so t goes on the outside, and then your pieces go up top. So negative 1 2/10 W, and then positive 3 goes over here.
I don't like that on fit.
Okay.
That's weird, dog.
It looks like so much more.
So now it's like a multiplication chart. These two, and then these two. Okay? Although you might not like this method, I'm not requiring you to do this method, right?
I don't like that method.
This is how we started learning multiplication in second grade.
Right.
Use 4 boxes.
So again, it's just like the 5 different methods I taught you last week when we were simplifying expressions. I taught you the closet method, the color method, the shape method, the loop method, and then the commutative/associative property problem, right, method. I didn't care which one you used. I just wanted you to have a lot of options. So again, here are your 2 options. You can use your arrows. You can use the box method. If you don't want to use either, that's fine, right? I'm okay with it. Okay. So the other thing that when we were talking about this is yesterday we modeled the distributive property as repeated addition, right? So I added G minus 9, G minus 9, G minus 9, G minus 9, G minus 9. I added all those together, and then I did the shapes. Circle around the G's 5 times, and then a box around the negative 9 5 times. This is a perfect example of why we can't always use repeated addition. We don't know what the value of t is, so we don't know how many times we're going to add negative 1 2/10 W plus 3, right? So that's why we have the shortcut of the distributive property. All right, here's our last one of the day. Okay, so our last example.
Hey, Homer.
Yeah, honey.
Why are you saying yes?
Hey, go sucker.
You know what's wrong with Tucker.
This is really easy.
Okay, so our expression is negative 1/3. Okay. Negative 1/3 times the quantity of 2 minus 3x plus 3. Now, what do you notice about this problem? Specifically, what's inside the parentheses? What do you notice?
Negative numbers and
There's 3 different numbers.
Okay, there's 3 different numbers, right? There's a 2, a negative 3x, and a 3. So what do you want to do? And there's a fraction as a coefficient, right? Zach, what do you want to do?
Combine the 2, or combine the constant.
Oh, could you combine the constants in this problem?
Yeah.
Yeah. Okay, so we've got positive 2 and a positive 3. Can we just rewrite that as 5?
Yeah.
Oh, yeah, absolutely. Now, how does that help us?
It takes away an extra number that we don't need.
Very good. It takes away an extra step. Do you have to do that step?
No.
Absolutely not. Okay? But you are going to then have to combine at the end. Okay? So whether you combine at the beginning or whether you combine at the end, you have to decide. I think combining at the beginning in this problem is easier, and then we'll talk about why though. Okay? So here we are. Negative 1/3 times negative 3. Hold on. Negative 1?
I got 1.
1.
Because there's 2 negatives.
Okay? Negative times a negative is a, and then 1/3, there's 1/3. Whoops.
Potty mouth.
I said turd. Okay. All right. 1/3 and 3, they're reciprocals of each other, so their product is 1. Okay. Everyone okay with me just writing x? Yeah. Can I write 1x?
Yeah.
Yeah, but do I need it? No. Okay.
Oh, okay.
All right. Negative 1/3 times 5. Positive times a negative times a positive is a negative, and then 1/3 times 5.
Negative 1 and 2/3.
Negative 1 2/3.
Yes, I want negative.
Yeah.
Yeah, I don't want 2/3.
I got this.
It's the same thing.
It,
It's still the same thing.
It makes life a little,
It's just
answers?
Yes.
Yes.
Absolutely I would. Alright, so here's what I want to show you.
That's like magic, jeez.
You could
It
have
is
just
called
pressed
Control G, but like,
It is how long?
How could I press Control G on here?
Yes.
I don't know.
Yeah. Okay. I've been doing this for a long time, right? So 14 years of teaching in the classroom, and then during my student teaching, my supervising teacher had a smartboard, and she was like smartboard guru. So like everything, I mean, she taught me everything I know, and I've just been getting better since then. And I use it every day too. A lot of teachers don't use it like this every day. You know, a lot of people just use it as a projector.
Yeah, that's what
That's
it's
what Mr.
called.
Fox.
But I just, and that's okay. That's, people have their own comfort zones. I'm just used to using it, right? So, here we combined 2 and 3 the first step, right? So I could do this. Okay, I could do that. So now I can group my like terms. Why did I make this 3/3?
because
That's 3/3 a whole.
3/3 is a whole, and now I have what?
Two.
Even if I was not.
I've got common denominators, right? So same sign,
And.
add, so 2 plus 3 is 5/3. Okay? So, okay, in this one here, I combined first, and then in this one here, I combined last. Did I get the same answer?
Yes.
Absolutely. Does it matter where you do that? It doesn't matter. Why is doing it first in this problem easier?
Because you can get rid of those extra numbers and just have one number second two.
Okay, here we added 2 whole numbers, right? Here I had to add a fraction and a whole number.
And adding two numbers.
So if you didn't have a calculator, this one would be easier, right, than having to do this. So that's just something to think about when you're doing these problems. Again, it doesn't really matter where you do it. All that matters is that, sometimes you're going to work with whole numbers, sometimes you're going to work with fractions. So it's your comfort level, right? Okay. All right, so let's talk about your homework for tonight.
Why do we keep saying yes?
Yeah, when I'm telling you nothing,
Yeah, but
I'm telling you that's-
even if it's easy, I don't really feel like
It's gonna be 5 problems.
This is true. Okay. So I would like for you to do.
Oh, she's in that did the waste part, no.
All right. So pages 211 and 212. So I want you to do number 16. And then I want you to do 21 through 23.
work together.
Okay, so that's 4 problems. Okay?
Just me, or do teachers just like always pick like on the word problem?
There's a word problem, 1 multiple choice, 1 multiple answer.
Yeah, there's 2 word problems, 1 multiple answer, and then 1 multiple choice.
I hate word problems because I
Well,
think it's easy.
the majority of your state tests, the majority of your SAT or ACT will be word problems, so.
Maps told me I was gonna fail both of those.
Who?
Maps.
Yeah, they really
I'm
do.
being
Okay,
serious, it's
alright,
not
so
math.
homework, page 211 to 12, 16, 21, 22, and 23.
That's a very dumb problem.